Imagine a world where the boundaries of time and technology blur. Imagine reliving the golden age of computing, not just through dusty hardware, but with the power and flexibility of modern systems. This is the ambitious goal of Project Manhattan, a revolutionary emulator designed to bridge the gap between the past and the present. At its core, Project Manhattan is about making the past accessible. It aims to faithfully recreate the experience of using classic computer systems, complete with their unique quirks and capabilities. This is achieved through emulation, a sophisticated process of mimicking the behavior of one system on another. Project Manhattan focuses on a specific type of system, the combined CPU-GPU architecture. This approach allows for a more holistic emulation experience, capturing not only the computational power of vintage CPUs, but also the graphical fidelity of their accompanying graphics processing units. This project opens up a world of possibilities, from preserving digital heritage to exploring the evolution of computing. It's about more than just nostalgia. It's about understanding our technological roots and using that knowledge to inspire the future. To understand the significance of Project Manhattan, we need to delve into the heart of any computer system, the CPU and GPU. These two components are the driving force behind the performance and capabilities of modern computing devices. The CPU, or Central Processing Unit, is often referred to as the brain of the computer. It handles the execution of instructions, the manipulation of data, and the overall flow of information. Essentially, it is responsible for carrying out the commands that allow software to function. The GPU, or Graphics Processing Unit, on the other hand, is a specialized electronic circuit designed specifically for rendering images, videos, and other visual elements. It excels at handling complex mathematical calculations required for graphics rendering, making it indispensable for gaming, video editing, and other visually intensive tasks. Think of it as the artist of the computer, taking data from the CPU and transforming it into the images we see on our screens. This synergy between the CPU and GPU is what enables the creation of stunning visuals and smooth user experiences in modern applications. In the early days of computing, these two components were often separate entities. The CPU would handle all the processing tasks, while the GPU, if present, was a simple, less powerful component dedicated to basic graphical tasks. However, as technology progressed, the lines began to blur, leading to the development of combined CPU-GPU systems. This integration allowed for more efficient processing and better performance, as the two components could work more closely together. These systems, often referred to as systems on a chip, SoC, integrate both the CPU and GPU onto a single chip. This not only saves space, but also reduces power consumption and increases the speed at which data can be processed and rendered. Project Manhattan recognizes the importance of this architectural shift and focuses on emulating systems with this combined approach. By doing so, it aims to preserve the intricate balance and performance characteristics of these integrated systems. By doing so, it can provide a more accurate and complete representation of how these systems operated, including their graphical capabilities. This is essential for both historical preservation and for understanding the technological advancements that have shaped modern computing. This is crucial for understanding the evolution of computer graphics and for preserving the visual experience of classic software. By studying these advancements, we can appreciate the journey from simple, pixelated images to the rich, immersive graphics we enjoy today. One of the fascinating aspects of Project Manhattan is its focus on systems built around the MOS 6510 microprocessor. This 8-bit marvel, released in 1982, became the heart and soul of the iconic Commodore 64 home computer. The MOS 6510, with its elegant design and versatile instruction set, played a pivotal role in the home computer revolution. It powered countless games, applications, and creative endeavors, leaving an undeniable mark on the history of computing. Project Manhattan, by emulating this chip, allows us to revisit this era and experience the ingenuity that went into these early systems. The C64, with its vibrant community and enduring legacy, serves as a prime example of the impact of the MOS 6510. Games like Donkey Kong, Manic Miner, and Impossible Mission pushed the boundaries of what was thought possible on an 8-bit machine. emulating the MOS 6510 is no easy feat. It requires a deep understanding of the chip's architecture, its instruction set, and its interaction with other components. Project Manhattan tackles this challenge head-on, striving for accuracy and authenticity in its emulation. Section 4. Breathing life into the past. The Art of Emulation. Emulation at its core is the art of deception. It's a sophisticated dance between hardware and software, a meticulous process that requires both technical prowess and creative ingenuity. It's about convincing software designed for one system that it's running on its native hardware, even though it's actually being hosted on a completely different platform. This involves a deep understanding of the original system's architecture and behavior. Imagine building a virtual stage that perfectly mimics the acoustics, lighting, and ambiance of a grand concert hall, allowing musicians to perform as if they were on the real stage. This analogy helps us grasp the complexity and precision required in emulation. That's essentially what an emulator does for software. It creates a bridge between the past and the present, enabling old software to run on modern hardware without a hitch. It creates a virtual environment that replicates the behavior of the target system down to the smallest details. This includes mimicking the timing, processing power, and even the quirks of the original hardware. This includes emulating the CPU, which is the brain of the computer, handling all the instructions and processes. The GPU, which renders graphics, the memory, which stores data, the sound chip, which processes audio, and other crucial components. Each part must be accurately replicated to ensure the software runs smoothly. The goal is to create an experience that is as close to the original as possible, allowing users to run software and play games just like they did back in the day. This not only preserves the software but also the cultural and historical context in which it was created. This is no small feat, and it requires a deep understanding of both hardware and software. Engineers and developers must work together, often reverse engineering old systems to understand their inner workings. Emulators like Project Manhattan are marvels of engineering, allowing us to bridge the gap between different generations of technology. They enable us to run software from decades ago on today's advanced systems. They open up a window into the past, allowing us to experience the software and games that shaped the digital landscape we know today. Through emulation, we can preserve and celebrate the rich history of computing, ensuring that these digital artifacts are not lost to time. Section 5. FreeBASIC, the foundation of Project Manhattan. The success of any software project hinges on the tools used to build it. The choice of programming language and development environment can significantly impact the project's trajectory, influencing everything from performance to community engagement. In the case of Project Manhattan, the developers have chosen FreeBASIC as their language of choice. This decision is rooted in a deep understanding of the project's unique requirements and goals. This decision is far from arbitrary. It speaks volumes about the project's commitment to accessibility, performance, and community. By opting for FreeBASIC, the team ensures that the project remains open and approachable to a wide range of developers. FreeBASIC, as the name suggests, is an open-source compiler for a dialect of the BASIC programming language. This language has a rich history and has been a gateway for many into the world of programming. Known for its speed and efficiency, FreeBASIC allows developers to create programs that run remarkably close to the performance of those written in lower-level languages like C or C++. This is particularly important for Project Manhattan, where performance is a critical factor. This is crucial for emulation, which often requires squeezing every ounce of performance out of the host system. The ability to write high-performance code in a more accessible language is a significant advantage. Moreover, FreeBASIC's clear syntax and familiar structure make it easier for developers to contribute to the project. This lowers the barrier to entry, allowing more people to get involved and make meaningful contributions. This open approach fosters a sense of community and encourages collaboration, which are essential for a project as ambitious as Project Manhattan. The collaborative nature of open-source projects can lead to innovative solutions and rapid development. By choosing FreeBASIC, the developers are not only building a powerful emulator, but also cultivating a vibrant community around it. This community-driven approach ensures that the project can grow and evolve with the input of its users. This choice highlights the project's commitment to making emulation accessible to a wider audience. By leveraging the strengths of FreeBASIC, Project Manhattan aims to democratize access to emulation technology. FreeBASIC's open-source nature and active community make it an ideal choice for a project that aims to preserve and share the history of computing. The language's legacy and ongoing development align perfectly with the goals of Project Manhattan, ensuring that the project remains relevant and impactful for years to come.